Elon Musk's Tesla Optimus and the 1X Neo robot. You've probably seen them all over social media doing incredible things, and you might be wondering, this looks amazing, but when can I actually get one of these? Well, I spent weeks diving deep into both Elon Musk's Optimus and 1X's Neo, and here's what surprised me. One of them you can actually order and have in your home next year, and the choice between them isn't what you'd expect. Welcome back to bitbiased.ai, where we do the research so you don't have to. Join our community of AI enthusiasts. Click the newsletter link in the description for weekly analysis delivered straight to your inbox. So in this video, I'm breaking down everything you need to know about these two AI-powered robots, their real capabilities, the artificial intelligence running their brains, what they can actually do today, and most importantly, which vision of the future is closer than you think. By the end, you'll understand why one is heading to your workplace while the other might be folding your laundry next year. First up, let's talk about what makes these machines so fundamentally different. What these robots actually are. When you look at Tesla Optimus and 1X Neo side by side, the first thing you'll notice is they're built for completely different worlds. And that difference starts with their physical design. Tesla's Optimus stands at about 1.73 meters tall, roughly the height of an average adult, and weighs 57 kilograms. Think of it as a mechanical coworker. It's packed with the same electric actuators and battery technology Tesla uses in their cars, which means it's built for endurance and power. But here's where it gets interesting. The latest Generation 3 model has hands with 22 degrees of freedom. To put that in perspective, that's almost as flexible as human hands, allowing it to grip, twist, and manipulate objects with remarkable precision. Now, 1X's Neo takes a completely different approach. It's smaller at about 1.68 meters and significantly lighter at just 30 kilograms, less than half the weight of Optimus. But don't let that fool you. Neo was designed from the ground up for one specific environment, your home. Its entire outer body is wrapped in a soft, 3D printed lattice polymer that acts like a cushion. This isn't just about aesthetics. It's a safety feature. If Neo bumps into your kid or your furniture, that compliant skin absorbs the impact. And this is where Neo's engineering really shines. Despite being lightweight, it uses what's called a tendon drive actuation system. Instead of traditional motors directly moving joints, Neo has high-torque motors connected to artificial tendons, mimicking how human muscles work. The result? Incredibly smooth, gentle movements that feel natural rather than robotic. It can lift up to 70 kilograms briefly and comfortably carry 25 kilograms. That's your groceries, your laundry basket, or even a sleeping toddler. But wait until you see how these robots perceive the world around them, because that's where the real magic happens. How they see and sense the world. Imagine trying to navigate your house blindfolded while someone describes everything around you. That's essentially what older robots dealt with. But Optimus and Neo, they have better situational awareness than most humans. Optimus is basically wearing a self-driving Tesla's entire sensor suite on its body. It has 8 cameras positioned around its head and torso, giving it complete 360-degree vision. These aren't just cameras. They're the same FSD autopilot cameras that Tesla uses in their vehicles, processing the world in real time. On top of that, Optimus has tactile sensors on its fingertips and feet, force torque sensors in its ankles for balance, and ultrasonic proximity sensors to detect nearby objects. Here's what that means in practice. Optimus can simultaneously watch what's in front of it, behind it, and to the sides while feeling the texture and weight of objects it's holding, and sensing how much pressure it's putting on the ground. It's operating with more sensory input than you use when you're walking and texting at the same time. Neo takes a similar approach with its own twist. It has a 360-degree sensor ring wrapped around its body, cameras and depth sensors feeding constant data about its environment. Those sensors let it navigate cluttered spaces smoothly, avoiding that stack of books you left on the floor or the dog that just wandered into the room. And here's something remarkable. Neo operates at about 22 decibels of noise. That's quieter than your refrigerator humming in the background. You could have it cleaning your kitchen at 2 a.m. and never know it was there. But sensors are just the eyes and ears. The real question is, what's doing the thinking? The AI brains behind the bots. This next part will surprise you, because the artificial intelligence running these robots is what separates them from every clunky humanoid that came before. Tesla made a brilliant strategic decision with Optimus. Instead of building a robot AI from scratch, they asked, what if we just repurposed the brain of our self-driving cars? And that's exactly what they did. Inside Optimus's chest sits the same Tesla full self-driving computer that's in their vehicles. The same neural networks that help a Tesla navigate city streets and avoid obstacles have been retrained to help a bipedal robot walk through factories and warehouses. But Elon Musk took it a step further. In 2025, he confirmed that Optimus version 3 now integrates Grok, Tesla's large language model. This means Optimus doesn't just see and move, it understands language naturally. You can tell it what to do in plain English, and it comprehends context, intent, and nuance. It's running what Tesla calls a foundation model architecture, a unified AI system that fuses vision, language, and motion control into one continuous learning loop. Think about what that enables. Optimus isn't following a flowchart of if-then statements. It's using the same technology that powers ChatGPT combined with computer vision to understand commands like, grab that red box and put it on the top shelf, but be careful because it's fragile. That's genuine intelligence at work. Now, 1X went in a completely different direction. They built something called Redwood, a vision language transformer trained specifically for household manipulation. While Tesla leveraged their automotive AI, 1X created a custom embodied AI model from the ground up. Here's how Redwood works. During training, human experts teleoperated prototype NEO robots through thousands of household tasks, folding towels, opening doors, loading dishwashers. Redwood observed not just the visual input, but also the joint positions, the forces applied, and the sequential steps. It learned patterns. Now, when you ask NEO to do something it's never done before, say, pick up a bowl shape it hasn't encountered, Redwood can generalize from its training and figure it out. And this is crucial. Redwood runs entirely on NEO's onboard GPU. It's not constantly pinging cloud servers for instructions. That means your robot keeps working even if your Wi-Fi goes down and your data stays private in your home. NEO also has its own built-in language model for conversation. You can chat with it, ask it questions, have it suggest recipes while it's organizing your pantry. But the most fascinating aspect of NEO's AI is its learning loop. Every task it performs, successful or failed, feeds back into the model. 1X has created what they call a continuous learning system. Early adopters might encounter tasks NEO doesn't know how to do yet. When that happens, a 1X expert can remotely guide the robot through the task once, and NEO learns from that demonstration. The next time it encounters something similar, it handles it autonomously. Your robot literally gets smarter the more you use it. So we have two fundamentally different AI approaches. Tesla's repurposed automotive intelligence combined with LLMs versus 1X's purpose-built embodied AI. Both are impressive. Both are learning systems, but they're optimized for very different environments. What they're actually doing right now. Now here's where things get real. Because we're not talking about vaporware or concept demos anymore. These robots are doing actual work today, and the use cases might surprise you. In July 2025, Tesla did something unprecedented. They took Optimus out of the controlled lab environment and put it to work at their new retro-themed diner and drive-in in Los Angeles. Not as a publicity stunt with handlers standing by, as an actual employee. An Optimus robot was autonomously scooping popcorn and handing it to customers. Real people, real popcorn, real service. Let that sink in for a moment. A humanoid robot was performing a repetitive customer service task in a public venue, interacting with surprised diners, and from all reports, doing it successfully. This was the first time a Tesla Optimus performed useful work in a public-facing role. Previously, all demonstrations had been internal or at private events, often with significant teleoperation behind the scenes. But Tesla's ambitions extend far beyond serving snacks. Throughout 2025, they've been deploying hundreds of Optimus robots in their own factories. These units are handling assembly line tasks, moving batteries, sorting components, carrying materials. Tesla's been showcasing Optimus doing everything from balancing on one leg to maintaining yoga poses, demonstrating the kind of dynamic stability you need when working in unpredictable industrial environments. Elon Musk's stated goal is to have about 5,000 Optimus robots in operation within Tesla by the end of 2025. That's not a pilot program. That's an army. And the roadmap is aggressive. They plan to start selling Optimus to other businesses in 2026, with consumer models available by 2027 at a target price of $20,000 to $30,000. Meanwhile, 1X Neo is taking a different path to market. As of late 2025, Neo hasn't started working in diners or factories because that was never the plan. Instead, it's been an intensive development for the one place that matters most: your home. Journalists and early testers who've spent time with Neo prototypes report that it can already handle a surprising range of household tasks. It folds laundry with reasonable accuracy. It can load and unload dishwashers, pick up clutter, water plants, and navigate around furniture and pets. These aren't carefully choreographed demos. These are actual domestic chores performed autonomously in cluttered real-world environments. But Neo offers something Optimus doesn't: companionship. Built into Neo's programming is the ability to interact socially. It listens, responds to questions, tells jokes, offers advice, and can even suggest recipes based on ingredients it sees in your kitchen. 1X is positioning Neo not just as a household appliance, but as an intelligent presence in your life, a helper that's always there when you need it. Now here's the part that makes this real. 1X opened pre-orders in late 2025. You can reserve a Neo right now with a $20,000 deposit or sign up for a subscription model at $499 per month. And they're not talking about shipping in 5 years. First deliveries are scheduled for 2026. That's next year. Early adopters will receive what 1X calls foundational autonomy. Neo can already perform basic tasks, and each software update adds new capabilities. It's an evolving product that gets more capable over time. For complex tasks it hasn't learned yet, 1X experts can remotely guide the robot through the process once, and then Neo adds that skill to its repertoire. So the current state is fascinating. Optimus is working in Tesla facilities and public venues right now, proving itself in industrial and service contexts. Neo is preparing for consumer launch, with the first units heading to homes in less than a year. 2 robots, 2 timelines, 2 completely different deployments. The competing visions of tomorrow. But to really understand these robots, you need to understand the philosophies driving them. Because Elon Musk and the founders of 1X have radically different visions of what a robot-filled future looks like. Elon Musk thinks bigger than almost anyone in technology. When he talks about Optimus, he's not just describing a useful product, he's describing a civilization-scale transformation. In 2024, when someone suggested there might be 1 billion humanoid robots on Earth by the 2040s, Musk's response was essentially, yeah, probably something like that. 1 billion robots. Think about that number. That's more than 1 robot for every 8 people currently alive. And Musk isn't just spitballing. He believes Optimus could eventually be more significant to Tesla's business than their entire vehicle division. He's said that explicitly at investor meetings. His vision is a world where Optimus and robots like it do anything humans don't want to do. The dangerous jobs, the repetitive tasks, the physically demanding labor that slowly breaks down human bodies. He imagines every household having a personal robot assistant. Factories staffed by thousands of tireless mechanical workers, and eventually, these robots helping humanity expand beyond Earth. He's even joked about sending an Optimus to Mars in 2026 alongside SpaceX missions. Musk sees this as solving fundamental economic challenges. aging workforces, labor shortages, dangerous working conditions. His endgame is a post-scarcity society where intelligent machines handle the grunt work and humans are freed to pursue creative and fulfilling endeavors. It's an audacious, almost utopian vision tied directly to his broader goals of sustainable energy, space colonization, and artificial intelligence. 1X Technologies, led by CEO Bernd Bernich, has a more grounded but equally compelling vision. They're not thinking about Mars or factory revolutions. They're thinking about your Tuesday evening when you get home exhausted and there's a mountain of laundry waiting for you. Bernich talks about NEO as closing the gap between our imaginations and the world we live in. He's referencing decades of science fiction where robots seamlessly integrated into daily life. Think Rosie from the Jetsons or the helpful droids from Star Wars. 1X's pitch is that NEO finally makes that a reality, not in some distant future, but right now. Their focus is quality of life improvement. They envision Neo helping busy parents juggle work and family by handling time-consuming household chores. They see Neo assisting elderly people who want to age in place independently but need help with physical tasks. They imagine a generation-defining technology that's as transformative as the smartphone, something that becomes a standard part of how we live. Critically, 1X emphasizes safety and user control. NEO is designed to be provably safe, and the company stresses that owners always remain in control. There are manual override options, and the robot's compliant body design means it can't accidentally hurt someone. This is about bringing helpful intelligence into homes without the fear factor. Where Musk talks about millions and billions, 1X talks about individual households and tangible improvements to everyday life. Where Tesla is building an industrial platform that can scale to any use case, 1X is crafting a home companion optimized for domestic environments. Both visions are compelling. Both could coexist. But they represent different philosophies about how robots integrate into human society. One from the top down through industry and infrastructure, the other from the bottom up through individual homes and personal relationships. How we got here and where we're headed. To appreciate how remarkable these robots are, you need to understand just how far and how fast the field has progressed. 20 years ago, humanoid robots could barely walk without falling over. Boston Dynamics robots were revolutionary just for being able to navigate rough terrain. Honda's Asimo could walk upstairs, which was considered cutting edge. Those robots were mechanical marvels, but they were essentially programmable machines. They followed predefined movement patterns. They couldn't learn, couldn't adapt, couldn't understand context. They were sophisticated puppets controlled by clever code. What changed everything was the AI revolution of the 2010s and 2020s. Deep learning transformed computer vision. Suddenly, machines could recognize objects as reliably as humans. Natural language processing made conversational AI possible, the same technology behind ChatGPT. Reinforcement learning allowed systems to improve through trial and error. And crucially, the computing hardware got powerful enough and cheap enough to run these AI models in real time on mobile devices. Tesla's Optimus exists because they already had the FSD computer and the neural networks for autonomous driving. Elon Musk realized that a self-driving car is essentially solving the same problems as a walking robot. Perceive the environment through sensors, predict what's going to happen next, plan a sequence of actions, execute those actions smoothly. The same AI that navigates a car through San Francisco traffic can navigate a robot through a warehouse. 1X's NEO exists because breakthroughs in transformer models and embodied AI made it possible to train a robot on household tasks using relatively limited data. The Redwood model, a vision language transformer with about 160 million parameters, can run on a robot's onboard GPU because modern chips have become incredibly efficient. These technologies couldn't have existed 5 years ago. The hardware wasn't there. The AI models weren't sophisticated enough. The training data wasn't available. But in 2025, everything converged. We're in this extraordinary moment where the technology, the business models, and the market demand all aligned simultaneously. And the pace is accelerating. Every improvement in large language models makes robots better at understanding instructions. Every advancement in computer vision makes them better at manipulating objects. Every breakthrough in materials, science makes them safer and more capable. This is compound progress. Each innovation builds on the last. Within 5 years, household robots might be as common as Roombas. Within 10 years, most manufacturing facilities in developed nations could have humanoid robots working alongside humans. Within 20 years, the idea of doing your own laundry might seem as outdated as washing clothes by hand in a river. That's not science fiction speculation. That's extrapolating from current trajectories and existing technology. The robots are here. They work. The question isn't if anymore, it's when and how fast. So here's what you need to remember. We're witnessing two parallel revolutions happening simultaneously. Tesla's Optimus represents the industrialization of humanoid robotics. Scalable, powerful, designed for work environments, and backed by one of the world's most advanced AI companies. It's the robot that will transform factories, warehouses, and eventually service industries. 1X's NEO represents the personalization of humanoid robotics. Safe, gentle, optimized for homes, and actually available for purchase right now. It's the robot that will transform how we handle domestic life, particularly for busy families and aging populations who need assistance. Neither is better. They're solving different problems. But both are powered by the same underlying revolution. Artificial intelligence has finally reached the point where it can give robots genuine autonomy and adaptability. These aren't pre-programmed machines anymore. They're learning systems that improve over time. 5 years ago, this video would have been pure speculation. Today, it's reporting on shipping products. That's how fast this field is moving. And if you're excited about AI, machine learning, and robotics, this is your moment to pay attention, because the next decade is going to be absolutely wild. What do you think? Are you ready to have a robot helping around your house? Would you trust one to work alongside you? Drop your thoughts in the comments. I read every single one. And if you found this breakdown valuable, hit that like button and subscribe, because we're going to keep tracking these developments as robots go from lab experiments to everyday tools. The future is here. It walks on 2 legs, and it's smarter than you think.